Welcome to the lecture series on vitamins and nutrition. Today, we are going to look at one more topic on vitamin C. And in the previous session, we were looking at overall physical chemical properties and overall functions of vitamin C. Today, we are going to look at the historic background of vitamin C discovery, who all were involved, and how the structural elucidation of vitamin C was done. And we are going to go into the details of absorption of vitamin D and how vitamin D is metabolized in human body. And then we are going to look into the deficiency diseases. So probably we are going to start with a little intro we have already done in the previous session that would have given you a picture of what vitamin C is doing in our system. And we saw what is a peculiarity concerned with vitamin D synthesis. So it's a water soluble vitamin, as you know, and this particular vitamin, especially in primates, human beings, bats, guinea pigs, since we lack one of the key enzymes in synthesizing this vitamin, we are left with dietary dependence of vitamin C. So we are going to look at the structure of vitamin C. So this is the chemical name for vitamin C, ascorbic acid, hexuronic acid, and you have one more synonym, anti-scorbutic acid. The original name was hexuronic acid because it contains 6 carbon atom. And now the official name of vitamin C is L-ascorbic acid. Chemically it's known as 2,3-endiol L-gulonic acid gamma lactone. Now we are going to look into the historic background. So you see the interesting crystal structure under polarized light, the crystals of vitamin C glittering. So we are going to look into the historic background of vitamin C. If you turn back the annals of history, way back in 400 BC, we do have notes by one of the great physicians, Greek physician, Hippocrates. He describes the symptom of scurvy. So it means this particular vitamin deficiency was known centuries before, but probably people were not really aware of the actual chemical ingredient. And now in this part of the history, we know very well what particular vitamin that we are talking about. But clinically, the symptoms described by Hippocrates are almost the same even in this generation when we talk about scurvy. See, there is always this trend among the ancient physicians to document clinical conditions based on symptoms. Maybe in this century and centuries before, when people have done a very systematic scientific study, people could understand exactly what's going on, and now we have redefined the pathology in detail. But earlier science, medical history, especially concerned with vitamin deficiency, was more of symptomatic documentation of a disease condition. So there is always problem because people could always misunderstand the symptoms because some of the symptoms could be redundant among different vitamin diseases. Yes, it's there are some typical symptoms concerned with every ingredient in the vitamin, but more or less some of the symptoms which happen to be common could be misunderstood. So that's one difference we find when we have to look into the documentation of clinical symptoms centuries before, when the actual scientific or rationale behind the pathology was established. So you look at this word, ascorbic acid is normally associated with this word scurvy. So the very word scurvy has its origin from the etymology of the word scorbutus. Okay, so this was the disease that was documented thousands of years before, and we know one of the official documentation done by Hippocrates has very close resemblance to scurvy. But if you go back only in 1500s, there are some accounts of native North Americans using tea brewed from pine needles that they have used to treat a symptom resembling scurvy. But you know very well, they could not really ascertain the pathological background behind the disease, but the symptoms more or less are of close resemblance to scurvy, and you see the kind of material that they have used has been one of the natural sources of vitamin C. So, knowingly or unknowingly, they have found the remedy, and they have found that it's able to reverse the symptoms of scurvy. Now you have this official first documentation by James Lind. I have spoken about this condition in detail when I began about talking of water soluble vitamins. So I would like to reiterate few words about Dr. James Lind, who used oranges and lemons as a cure for scurvy. So this experiment was done in 1747. Interesting enough, so if you look at this, you find James Lind performing this study, but if you look at whether Dr. James Lind continued this as a standardized therapy or a remedy for treating scurvy, history says it was not so, because Dr. James Lind was able to associate taking oranges and lemons as a cure for scurvy, but personally was not like very much convinced about the therapy, and it seems that he had not made a standardized method of prescribing oranges and lemons for treating scurvy. So still there was a lacunae, and people could not conclusively relate scurvy with the ingredients present in oranges and lemons. Nevertheless, we could always consider this as an historic moment where people were able to ascertain some specific nutritive deficiency connected with a disease that could be or possibly reversed when you could supply back the required nutrient. Although we may not say that James Lind would proceed to discover vitamin C, and it's unlikely in that generation with scientific rationale growing up slowly, people were not fully aware of the implications of the study, that even Dr. James Lind was not fully aware of the implications of the study that he had conducted. Now we have to wait for some more time, and way back in 1907 you have scurvy being experimentally reproduced. So that would say only in the beginning of the last century that you find Hoist and Froelich are able to reproduce the condition. See, it's interesting. Now we know guinea pigs, primates, bats lack the ability to synthesize vitamin C. It's been really, I would say, a painstaking effort by Hoist and Froelich to ascertain the kind of model that they have selected for experimenting with vitamin C deficiency. So it's a very nice model we could appreciate now in this side of the history. And you see again in 1917 you find Chick and Hume could develop a bioassay in the model where they could identify an anti-scorbutic property of food. So now they have come very close. They are able to now classify the foods which could have a remedy for vitamin C deficiency. Still the name is not out, and now they are only coming to a point where you could reproducibly check the food quality in terms of its ability to treat scurvy. Now we wait for some more time till Dr. Zen Georgi comes into picture. I would say the moment he took this study, it was a real breakthrough, and years later he is going to be awarded Nobel Prize for the work that he is going to perform, and he is attributed in identifying the xuronic acid. So he could identify this particular acid, and he isolated it and he characterized it from adrenal glands, okay, of the pigs, and it was found that the extracts what he had purified were able to really treat the conditions connected with the symptoms of scurvy. And you find that he extracts large quantities of this particular substance from a natural compound, the sweet peppers, and we find this is the picture of Zsen Györgyi. So he's a Hungarian biochemist. So I purposely put one full set of slides for him because his contribution is really tremendous. And not only that, in fact, we always connect vitamin C with antioxidant property, and all antioxidants are free radical scavengers. In fact, you find Dr. Györgyi is attributed in starting up this science on free radical associated cellular damages, okay, and methods of combating that. In fact, towards the end of his scientific career, he started applying the quantum mechanical principles on cellular biology, and he, being a biochemist, was closely observing how the ingredients what he had isolated earlier, vitamin C, could be a remedy for treating this condition, and this paved the way for lots of cancer studies much later. Now this entire biology of free radicals and methods to really direct them in the proper way, and the natural way by which how the free radical scavenging happens, everything started with Györgyi and his discovery of vitamin C. So he had a very illustrious scientific career, and he was one of the stars during the Second World War among many other biochemists who had contributed a lot in vitamin related deficiency diseases. So we will always remember. So you see there, he could completely isolate, but he had to wait with a matching animal model to reproduce the ingredient what he had identified to be a cure for scurvy. So you see here Charles Glenn King of University of Pittsburgh. So he could make the right connection between hexuronic acid isolated by Györgyi, and now things are falling in line. So you see there in the King's laboratory, so Györgyi and their partnership proved to be very effective, and together they are now coming up with the name ascorbic acid. And you see here in this continuation of the work, it's been taken up by medicinal chemists, and we have Rechstein synthesizing ascorbic acid, and he found this much similar structurally to the vitamin C that they had identified with Györgyi's team. So they initiated large scale production of vitamin C, and you find Awath and Györgyi received Nobel Prize for their contribution in vitamin C discovery and its association with scurvy. So this all happens in 1937, and you have the Crandon proves the mandatory contribution of vitamin C in wound healing process. So still the history of vitamin C continues into 1970, and you find Dr. Pauling coming into picture, Linus Pauling, and he is an established scientist and he is already a Nobel laureate for his contributions in chemistry, physical chemistry primarily, the non-covalent interactions, and you find he draws further attention to vitamin C by making a connection between vitamin C and common cold. He is supposed to be one of the fond proponents of taking vitamin C to prevent common cold. As we all know, common cold virus is relatively a very unstable virus, and although we do not have medicines, the time in which people would suffer from common cold is considered terrible because the symptoms a typical of any flu, and although the recovery is good, the time spent always affects the quality life of an individual. And this suggestion by Linus Pauling as a cure, or probably a prophylactic cure against common cold, has now been scientifically proved, although it's not consistent in all the clinical trials that had been conducted earlier. But nevertheless, we can be convinced that there is a positive connection between vitamin C and common cold. And you see there in 1975 to 79, lots of work had been done by associating vitamin C for its antioxidant effect and its ability to scavenge free radicals. In 79, again Packer and co-workers observe the free radical interaction of vitamin E and vitamin C. Now things are getting into shape for nutrition industry. Now they could now narrow down and say the roles of vitamin E and vitamin C are complementary and are being established as an antioxidant combination. And the work continues further. Way back in 1982, you find Nicky demonstrates the regeneration of vitamin E by vitamin C in model reactions. So this is a very important clue as to how these antioxidant compounds help each other in the pathway of free radical scavenging. Now you find the industrial demand actually grows from 30,000 to 35,000 tons per year, 1985. And now people start discovering a connection between vitamin C and cancer therapy. So the National Cancer Institute of USA finds inverse relationship between vitamin C intake and various forms of cancer, and issues guidelines to increase vitamin C in the diet. So you find the more the amount of vitamin C a person could take, the better the person has a chance to keep cancer diseases at bay. Now it's become a standard practice that vitamin C can be given as a supplement as part of cancer chemotherapy to improve the outcome of responses. And now we know that vitamin C is also improving immune responses. So you find in 1998 and 99, 3 studies show that supplementation with vitamin C can dramatically lower lead levels. So you find now it's been used as an antitoxin for heavy metal toxicity, especially with lead. You do have the work being continued further in 2004, a systematic review of 30 studies is addressing the effect of vitamin C supplementation, which drastically reduces the duration of colds. So there is this consistent benefit. And now we find most of the general physicians, because we don't have much medicines available to treat common cold except for symptomatic therapy offered by physicians, and it seems this study had really boosted the sale of vitamin C and sale of vitamin C fortified food. And we are going to see shortly how vitamin C has additional benefits in food industry. But before we go to that, we have to go into more details of how vitamin C had been there as a functional vitamin in many metabolic process. So 2005, Levine calls for a re-evaluation of vitamin C as cancer chemotherapy, especially intravenous administration of vitamin C. And we find in 2006, a 5-year Japanese study showed the risk of contracting 3 or more colds in the 5-year period was decreased by 66% by daily intake of 500 milligram of vitamin C supplementation. So all this gives you a very good picture about how vitamin C is so essential as part of a daily diet. So you find all the giants who have contributed in the research, discovery establishment of vitamin C as an important food nutrition. And you have the picture, we have seen Georgi and King, their partnership had been really good. And here you have the picture of Reichten, who contributed in the structural elucidation. And here we have the picture of Linus Pauling, who had been a good person to propagate the use of vitamin C for common cold. Maybe not many studies had been done. Many studies had been done where we were able to relate, but now we could see how the claims of Linus Pauling had proved to be really good in treating common cold, and is credited to have 2 Nobel Prizes, first for his contributions in physical chemistry and now as a contribution that he has done in curbing nuclear weapons. But his contribution in vitamin C also, I would say, would deserve a real award, and he was also awarded many times for his contribution in healthy lifestyles. And true to his credit, he continued to take vitamin C almost a gram a day, and true to his conviction, he lived for more than 95 years, and that's an open evidence that his conviction about vitamin C's role in preventing cold and its role in antioxidant therapy had after all proved at least good for him. And now in this side of history, we know his claim and his conviction had been really true. Now we are going to look at basically the structure of vitamin D. I would like to draw the structure of vitamin C. So you see the lactone ring, and you have the keto group, you have the OH group. So this is carbon 2 and carbon 3, and you find carbon 2 and carbon 3, and here you have the side chain with the hydroxy group. So this is L-ascorbic acid, and now this L-ascorbic acid undergoes, I would say, a reversible reaction where it loses these 2 hydrogens, and that's one of the reasons now ascorbic acid is able to have its acidic property. So you find here the structure becomes L-dehydroascorbic acid. So this is actually the metabolism that happens in our body. Once ascorbic acid goes into systemic circulation, our body tends to oxidize ascorbic acid into L-dehydroascorbic acid. Now further, you find one more level of oxidation happens. Now this ring, lactone ring, is broken, and you find you have one more compound coming up because of oxidation. This compound is basically called 2,3-diketo L-gulonic acid. So it's been oxidized to L-dehydroascorbic acid, and then there is one more oxidation product which is 2,3-diketo L-gulonic acid. Now there is one more oxidation product coming up where we are going to go further from 2,3-diketo L-gulonic acid. There is one more product which is L-erythrulose. So now the compound becomes almost linear. So this is L-erythrulose, and finally it proceeds to become oxalic acid. So since it loses 2 protons, it's called oxalate. So as oxalate, it's eliminated in the kidney. So in our body, we find ascorbic acid getting converted to L-dehydroascorbic acid, then it gets into a keto compound 2,3-diketo-L-gulonic acid, which becomes L-erythrulose and finally to oxalate, and oxalate is eliminated by kidneys. It's interesting to note, suppose if a person is going to take too much of vitamin C, the accepted dosage is 1 to 2 grams maximum. A comfortable dose would be 500 milligrams of vitamin C per day. But some people, who are very health conscious and end up taking too much of vitamin C can actually have a trouble with this particular compound. Oxalic acid, since it's being eliminated in kidney, and if they don't take sufficient water, end up having kidney stones. So that's one reason why hypervitaminosis symptoms of vitamin C is closely associated with kidney stones, or technically we call it renal calculi. Okay, so best way is don't stuff yourself with too much of vitamin C more than required. I would say at least more than 1.5 grams per day, but that's very unusual to get that much amount of vitamin C in our dietary supplement. But I would say whenever we are taking more vitamin C, it's also equally advisable. Let's consider patients who are on vitamin C supplementation as part of their cancer chemotherapy or as a dietary supplement for specific reasons. They should be recommended to take plenty of water to enable them to eliminate oxalate by kidneys in an effective manner. So the lesson we take over here, vitamin C is good. It's good in the treatment of common cold. It's good as a dietary supplement. It has plenty of prophylactic uses, but a word of caution, considering the normal metabolic pathway, we have to be very, very clear as to how we are going to consider the metabolism of vitamin C elimination in our body. So this is a practical lesson. And now we are going to look at industrial production of vitamin C. So we have reached in 1933 after he elucidated and found the synthetic way of ascorbic acid. Later, in 5 years, the Hoffmann-La Roche developed an industrial process for vitamin C production. So I'm going to summarize today's talk. So we saw in detail the historic development of vitamin C, how scurvy was initially characterized, and a very systematic stage by stage development of many key scientists and scientific team in discovering the structure of vitamin C, associating vitamin C with scurvy, and we went further to look into the metabolism of vitamin C in human body, and we finished off with the industrial production of vitamin C. So I would like to conclude that right now the industrial demand for vitamin C is always there, it's always ripe, and the raw material being glucose. Okay, that's how it's been used by chemical and biotechnological methods to meet the demands, growing demands of vitamin C. So I would like to close with a question. Give me all the details of oxidation products that result from vitamin C intake as part of human physiology. So this is the question I want you to practice, and I already wrote the structural equations and the oxidation products that results in vitamin C metabolism in human body. Thank you for your attention.